Hi guys, welcome back to our discussion on Infinite Series. So in today's video, I talk about pattern recognition for sequences. So for this lesson, we will learn how to write a formula for the end term of a sequence. Sometimes it's difficult to identify the end term of the sequence. So in such cases, you may be required to generate some rule or discover a pattern in the sequence and to describe the end term. So once the end term has been specified, you can now investigate the convergence or divergence of the sequence. Okay, like for example, suppose we are asked to find the a sequence a sub n whose first five terms are given as follows. The first term is 2 over 1, the second term is 4 over 3, third term is 8 over 5, and so on and so forth. And then, you are also asked to determine whether the sequence you have chosen converge or diverge. So, from the given sequence, as you can see, the numerators are successive powers of 2. You have 2 to the 1, 2 squared, you have 2 cubed, 2 to the fourth, and 2 to the fifth. While the denominator, these are positive odd integers, so starting from 1. Okay, so from this given terms of the sequence, now we have to generate or discover some pattern or general rule. Okay, because the numerator are odd powers of 2, so you can write this as 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the fifth, and so on and so forth. So in general, this is 2 to the n. While the denominator are positive integers, so you have 1, 3, 5, 7, 9, and in general form, this is 2 times n minus 1. That if the value of n is 1, you have 2 to the 1 over 2 minus 1 or 2 over 1. If n is 2, then you have 2 squared over 2 times 2 is 4 minus 1. So that's 3. So you have 2 squared over 3. If n is 3, then you have 2 cubed over 2 times 3 is 6 minus 1. So you have 2 cubed over 5 and so on and so forth. And then after that, we can write the end term as a function of a real variable denoted by f of x, which is 2 to the x over 2x minus 1. And if you can recall the theorem 9.1, we have to evaluate the limits of this function. So to evaluate the limits of this function, we rewrite this in this notation as limits of 2 to the x over 2x minus 1 as x approaches positive infinity. And then we replace the x variable by infinity. So you have 2 raised to infinity over 2 times infinity minus 1 is infinity. So the numerator and the denominator are both infinity. So you have infinity over infinity. And if you can recall in calculus 2, this type of limits are indeterminate forms. So in this case, because the numerator and denominator are both infinity, so we can apply L'Hopital's rule to evaluate the limits. So differentiating the numerator and the denominator separately, have if you can recall, the differential of 2 to the x is 2 to the x times the natural log of a, where a here is 2, all over the differential of 2x minus 1, which is 2. And then after that, by replacing the x variable by infinity, you have 2 raised to infinity times the natural log of 2 is infinity divided by any constant 2 is infinity. So therefore, the limits of this function, 2 to the x over 2x minus 1, is equal to infinity. Then by applying theorem 9.1, we can now conclude that the limits of 2 to the n over 2n minus 1 as n approaches infinity is infinity. Now, because the limits of this function is infinity, so the limits of the n term of the sequence as n approaches infinity is also infinity. So this indicates that the sequence diverge. So in summary, to determine whether the sequence converge or diverge, the following steps must be followed. That number 1, you have to discover a rule or pattern in the sequence and describe the end term of the sequence. And then second, evaluate the limits of a sequence to investigate the convergence or divergence of the sequence. Okay, that's all for today. Thank you.